Britain sent its AS90 self-propelled howitzers to Ukraine. Roughly a third weren't even working, cannibalised for spare parts to keep the rest of the fleet limping along. And the barrel upgrade that would have transformed this weapon into a world-class NATO artillery platform? Cancelled. Because the gun sheds on British Army bases were physically too small to house the longer barrels. The 52 caliber upgrade would have added roughly 2 meters to each tube. Somebody at the Ministry of Defence looked at the vehicle shelters, looked at the barrels, and decided it was cheaper to abandon a generational artillery upgrade than to modify a building. A weapon system held hostage by the dimensions of a shed. And yet, despite the neglect, the cannibalisation, the institutional indifference, this 30-year-old howitzer is proving more reliable in actual combat than artillery systems costing twice as much. Keep it simple, stupid. Ukraine's battlefield is delivering the verdict that Westminster refused to hear, and the AS90 is its best piece of evidence. British artillery engineering carries a lineage of pragmatic cleverness that goes back generations, a stubborn, deeply institutional preference for weapons that work over weapons that impress. The BL 5.5-inch medium gun of the Second World War is where that tradition crystallised into something approaching doctrine. Entering service in 1942, the 5.5-inch wasn't the heaviest gun on any battlefield it fought on. It didn't need to be. British engineers developed steel alloys for the barrel that could withstand sustained firing without the exotic manufacturing processes their German counterparts demanded. The metallurgy was a masterclass in extracting maximum performance from available industrial capacity, optimising within constraints that the engineering team treated as features rather than limitations. Its 100-pound shell delivered destructive effect, rivaling heavier German pieces, and it earned that reputation across every theatre, from North Africa to Burma. Crews trusted it because it didn't stop working. Operational readiness stayed high because the design team had done something deceptively difficult. They'd systematically removed the things that break. Not by accident, by philosophy. Build for the mud, not the brochure. That idea didn't retire with the war. It crossed generations. And when VSEL won the contract to build Britain's next self-propelled howitzer in the late 1980s, the company carried it forward with the instinct of people who'd spent their careers building things that go to sea. VSEL, Vickers Shipbuilding and Engineering Limited, headquartered in Barrow-in-Furness, came from shipbuilding. In that trade, you engineer things to survive hostile environments because the alternative is that people drown. No second chances, no factory recall. The Royal Artillery's requirement reflected the same unforgiving logic. A 155mm self-propelled howitzer that could keep pace with armoured formations, deliver rapid fire, and be maintained in the field by regimental fitters rather than depot-level specialists flown in from somewhere comfortable. VSEL didn't try to dazzle the procurement board with theoretical maximums. They built a gun that soldiers could live with, fight with, and fix with their own hands. What entered service in 1992 reads like a deliberate manifesto for simplicity. The gun mounted a 155mm L/39 barrel, 39 calibers long, which was a conscious trade-off. It sacrificed theoretical maximum range in exchange for manageable weight, reduced barrel wear, and a lighter logistical burden. Every design decision that followed served the same calculus. The recoil system and hydrogas suspension allowed the AS90 to traverse and fire through a full 360 degrees without deploying stabilizing spades. Most self-propelled howitzers of that generation needed metal anchors hammered into the ground before they could shoot. a process that added critical minutes to every fire mission and transformed the vehicle into a stationary target for counter-battery radar. An AS90 crew could halt, fire and move before the enemy's return volley arrived. In burst mode, 3 rounds went downrange in fewer than 10 seconds. Sustained intense rate, 6 rounds per minute for 3 minutes straight. Lineage, the fire control system, built around a BAE Systems ring laser gyroscope inertial navigation unit, coupled with embedded military GPS, gave each gun autonomous capability. No external survey data required. No battery command post needed in the loop. A single AS90 could detach from its troop, compute its own position, lay the gun on target, fire, and displace independently. In an era when most artillery systems still depended on centralized command to function, VSEL handed each crew the ability to fight alone if they had to. Pushing 45 to 46 tons of armoured howitzer at 55 km per hour on roads was a Cummins VTA 903 TV8 diesel producing 660 horsepower. The engine choice was as deliberate as everything else. Cummins diesels were ubiquitous across military and commercial fleets worldwide. Spare parts existed in supply chains on every continent. Any competent mechanic had already worked on the engine family. Choosing that power plant meant that a broken-down AS90 in a forward assembly area didn't need exotic logistics to get running again. The parts and the expertise already existed wherever military and commercial vehicles operated. VSEL didn't design for ideal conditions. They designed for the conditions that actually exist. 178 AS9s rolled off the production line for the British Army. The gun proved itself under fire during Operation Iraqi Freedom in 2003, when 155mm batteries deployed alongside 1st UK Armoured Division during the advance on Basra. AS9s kept pace with Challenger 2 tanks and Warrior infantry fighting vehicles across southern Iraq, delivering responsive fire support in fast-moving combined arms operations. 3 AS90 regiments were maintained through the Army 2020 restructuring. The engineers had done their job. Soldiers who crewed the weapon trusted it. Everything that happened after was done to the AS90, not by it. From the earliest design stages, VSEL built the chassis, turret ring and fire control architecture to accept a longer barrel. Growth was always part of the plan. The AS90 Braveheart program developed and tested exactly that upgrade, replacing the L39 barrel with a 52 caliber variant, stretching the tube from roughly 6 meters to 8. Standard ammunition range would leap well beyond the original 24.7 kilometers, and with base bleed or rocket-assisted projectiles, the gun was projected to reach past 40 kilometers. NATO was standardizing on 52 caliber barrels through the Joint Ballistics Memorandum of Understanding, a decision that governed compatibility with the NATO modular charge system and precision-guided munitions like the Excalibur GPS-guided shell. An AS90 with its original 39 caliber barrel could fire 155mm shells. An AS90 Braveheart with the 52 caliber barrel could fire precision-guided munitions to 40 kilometers and integrate seamlessly with every NATO artillery system on the continent. D.B. Lawton and colleagues at the Defence Evaluation and Research Agency conducted detailed studies on thermal behaviour and barrel erosion characteristics specifically for the 52 caliber AS90 ordnance. They examined temperature and heat transfer at the commencement of rifling to optimise barrel life under the higher pressures the longer tube demanded. Serious metallurgical work. Serious ballistic engineering. The hydropneumatic suspension already had margin for additional recoil forces. Lineages could accept updated ballistic tables. The Cummins Power Pack had headroom. Textbook spiral development. Take something that works, make it better. Skip the catastrophic risk and expense of starting from scratch. Then the program died. Slow bureaucratic asphyxiation spread across multiple defense reviews and annual budget cycles, each one trimming funding until the effort couldn't sustain itself. The gun shed claim that vehicle shelters on British bases couldn't physically accommodate the longer barrels, and modifying those structures was deemed an unacceptable expense, circulates through military communities with the unmistakable ring of institutional truth. Whether shed dimensions were the proximate cause or simply the most absurd symptom of a deeper refusal to value capability over cost, the outcome was identical. Oscar Wilde diagnosed this species of institutional stupidity with permanent precision. A cynic is someone who knows the price of everything and the value of nothing. The MOD knew the price of the .52 caliber barrel, the modified shelters, the testing program. Nobody bothered to calculate the value of a competitive artillery capability maintained across 3 decades. Across the Channel, Germany was offering what looked like the answer. The Panzer Howitzer 2000 boasted everything the Braveheart would have provided and more. A .52 caliber barrel delivering extended range, a fully automated loading system promising extraordinary burst rates, advanced digital fire control, and the kind of polished specification sheet that makes procurement officials reach for their checkbooks. Germany positioned the PzH 2000 as the gold standard of NATO self-propelled artillery, and several nations bought into that vision. Then Russia invaded Ukraine. The PzH 2000 went to war for the first time, and the distance between the brochure and reality opened up fast. The automated loading system, centerpiece of the weapon's rapid-fire capability, proved mechanically sensitive to dirt, dust, and the omnipresent debris of combat in Ukraine. When the autoloader jams or malfunctions, crews can't switch to a degraded manual mode and keep fighting. Peak performance complexity becomes, at the moment of failure, a total system impediment. Electronics governing fire control, navigation, and ammunition management demand environmental conditions that are routine in a German garrison and absurd in a frozen Ukrainian tree line. Barrel wear under sustained combat firing. The relentless day-after-day tempo of a real artillery war, not a NATO exercise, has reportedly strained the supply of replacements. Multiple accounts describe the PzH 2000 spending more time under maintenance than delivering fire. For a weapon system whose entire value proposition rests on shooting faster and farther than anything else on the field, that's a fatal contradiction. And then there's the boots. Among operators and observers of the PzH 2000, a claim persists that crews are expected to change their footwear before entering the fighting compartment, swapping muddy field boots for clean shoes to protect sensitive electronics and deck plates. A weapon designed for the battlefield that asks its crew to treat the interior like a clean room. Contrast that image for a moment. An AS90 crew scrambles into their turret, wearing whatever's on their feet, puts 3 rounds down range in under 10 seconds, and displaces before counter-battery fire arrives. A PzH 2000 crew, according to this account, changes their boots first. The military enthusiast community spotted the pattern immediately. During the Second World War, the Tiger I tank was a technical masterpiece that spent more time broken down in specialist workshops than fighting, ultimately losing to the simpler, mass-produced Sherman. Same engineering culture, same institutional impulse, perfection on paper, paralysis in the field. What makes this comparison genuinely painful is how close Britain came to splitting the difference perfectly. The 52 caliber Braveheart upgrade would have matched the PzH 2000's range without importing its fragility. Every element that made the AS90 field maintainable would have carried over intact. Hydrogas suspension, spadeless 360-degree firing, autonomous limps gun laying, the Cummins diesel with its worldwide parts network, modular ammunition handling designed for soldier-level maintenance. Braveheart would have been a 52 caliber weapon with a 39 caliber maintenance burden. That combination barely exists in military procurement, where greater capability almost always drags greater complexity behind it. Lay the full sequence out and try to keep a straight face. In 1992, the AS90 enters British service, robust, effective, combat-proven in Iraq. An upgrade is developed, funded, and tested that would extend range by more than 60% and align the weapon with NATO standards. That upgrade is cancelled, reportedly in part because of building dimensions on garrison bases. The fleet ages without its life extension. Vehicles are progressively stripped to keep surviving guns running. When Ukraine needs artillery, Britain donates what remains, including guns that had been serving as organ donors for the rest of the fleet. Britain then discovers it has a critical gap in self-propelled artillery capability. The solution? 14 Archer-wheeled howitzer systems from Sweden as an interim measure. 14 guns. For an army that fielded 178 AS9s across 3 regiments. Archer is a competent platform, truck-mounted, 155mm automated loading. But 14 guns don't constitute an artillery capability for a country that claims to be a serious military power. 14 guns constitute a press release. The RCH-155, mounting a remotely controlled howitzer turret on the Boxer armoured vehicle, is the intended long-term replacement, but its procurement timeline stretches years into the future. Between AS90 retirement and RCH-155 delivery in meaningful numbers, the British Army's organic self-propelled artillery capability has undergone a reduction so severe that calling it a gap is generous. A gap implies 2 sides of a bridge. This is one side of a bridge and a distant prayer. No single government owns the blame. The Braveheart programme spanned multiple administrations and was eroded across successive defence reviews. The 2010 Strategic Defence and Security Review oversaw sweeping cuts to heavy armour and artillery, with the AS90 explicitly marked for reduction. The Henry Jackson Society's 2022 report on securing UK defence procurement documented the trajectory bluntly, noting decisions to reduce our heavy artillery, AS90 armoured artillery vehicles, as part of a broader sacrifice of conventional warfighting capability. Every government since the Cold War's end participated. The consistent villain isn't a party, it's the procurement system itself, with its revolving door ministers, treasury-dominated budgets, and an institutional addiction to cancelling proven programmes in favour of shiny replacements that are perpetually a decade away. If they'd funded the 52 caliber upgrade, Britain would still field a competitive artillery force today. Instead, the AS90 found its war somewhere else entirely. When Britain donated those howitzers to Ukraine, it shipped weapons the procurement system had abandoned, vehicles so depleted that some had been cannibalised to keep others alive. What arrived on the Ukrainian front wasn't a showcase of British military investment. Frankly, it was evidence of British military neglect repackaged as generosity. Ukrainian crews and maintainers, many of whom had trained on Soviet-era systems with an entirely different design philosophy, adapted to the AS90 and put it into frontline service. In a conflict defined by relentless artillery duels, counter-battery exchanges, and constant threat of precision strikes, the AS90's design philosophy delivers exactly what VSEL's engineers built it to deliver. The hydrogas suspension absorbs punishment on roads that have been churned into something between gravel and soup. Spadeless 360-degree traverse makes shoot and scoot reflexive rather than aspirational. The Cummins diesel is the kind of engine that field mechanics have an intuitive feel for. When something breaks, and in a war zone everything eventually breaks, modular components come out and go back in, with tools stowed in the hull. No factory technician, no 12-hour wait for a specialist recovery team. A field repair at 3 in the morning by soldiers who were trained to fix what they fight in, because VSEL designed it that way on purpose. That kind of engineering choice is invisible during a procurement competition. In a war, it's the difference between a gun that fights and a gun that waits. Britain was among the first nations to arm Ukraine. NLAW anti-tank missiles shipped before the full-scale invasion was even underway, Storm Shadow cruise missiles, and a sustained training pipeline through Operation Interflex that has put tens of thousands of Ukrainian recruits through basic soldiering. The AS90 donation sits within that broader pattern of early and consistent support. A sentiment keeps surfacing in British military communities whenever AS90s appear in Ukrainian combat footage. No caveats, no political qualifications, just a quiet, genuine warmth. Glad to see you putting them to great work. Pride that something built in Barrow-in-Furness is doing its job for people who desperately need a reliable weapon at their backs. The best tribute to good engineering was never going to be an upgrade program or a defense white paper. It's a gun that still works when everything around it's falling apart. Politicians gave up on the AS90, Ukraine didn't. And 30 years after it rolled off the production line, this straightforward, unglamorous, brutally practical howitzer is answering the only question that ever mattered. Does it work when someone's shooting back? VSEL's engineers already knew the answer. They built it into every weld, every bolt, every deliberate choice towards simplicity over sophistication. Ukraine is just confirming what the gun always knew about itself. Subscribe for more stories like this.